Let's build an oscillator, specifically a Wien Bridge oscillator with a sustained frequency of 10 kilohertz. And so let's start out with LTspice, and let's start a new blank schematic. Let me just make it as big as possible here on the screen. And we're going to use an op-amp as our amplifier. We're going to use positive feedback to create the oscillation, and we're going to utilize the negative feedback to control the amplification factor. And in circuits like these, you want an amplification factor of 3. So let's go ahead and pull out a component, and let's go ahead and start with an op-amp. Typically, I like the LT1001 for this particular application, so let me just go over there. That way I don't have to do much configuration. It's pretty straightforward. And that would be this one right here. And let's put it right smack in the middle of the screen. For now, let's go ahead and put up some power supplies to power up this op-amp. So I'm going to need something for VCC and VEE. So I'm just going to put them on the side here. Let's go ahead and get components. And I need VOLT. That's voltage, as you can see. That's what I'm picking. It's a DC power supply. I'm going to need 2 of them. I'm going to put them in series. So let me just move them as far away as possible here. And right there. Next, I'm going to need to connect these power supplies to the op-amp. So as you can see, I'm doing this as if we're in the lab and connecting the everything with wires after we've put our op-amp, which usually comes in an IC chip. Depends if it's quad or dual. So you'll have to consult with the packaging for that chip. And this would be VCC here. And this one here will be VEE, or the minus or the negative power supply source. Okay, for this to work, we're going to need to ground. So let me just put an extra wire here. Just go from here to here. And I'm just going to go this way. Just hit escape. And I'm going to put a ground in the middle, which is really a reference. So I am going to go to net name, pick a ground right here, and stick it at the end of this wire. So this will be our reference here. So if you measure here, you will get whatever this voltage here as a negative value, and this one, whatever this voltage here is, as a positive value. So if you want, you can actually label this VCC. Let's do CC lowercase here. And this would be VEE. These are DC power supplies. We can give them values if you want. So VEE. Another thing is, these values are going to be important as far as the amplitude of the sustained signal that comes out of the oscillator. So let's put 9 volts here. So we should be a little below 9 volts in terms of the peak value. Okay, so this would be 9 as well. There you go. All right. So now let's go ahead and create the negative feedback, which translate into the amplification factor for this circuit. And we're going to do it by an amplification factor of 3. So we will use maybe 30 kilo ohm for the feedback resistance, which means the other resistance, or the one at the inverting input, will be 10 kilo ohm. All right, well, let's do that. Let's go ahead and get some components. Let's call it resistor. Okay, and I'm going to put this one right here. That's a good place to put it. Oh, by the way, let me go ahead and put another one right here for the network for the positive feedback. I'm just going to put it in here because I'm going to need 2 verticals and 2 horizontals. So let's go ahead and Control R in here. This would be my negative feedback. So this, we'll put it right here. And we're going to do another one here for the positive feedback for the oscillating circuits. All right, so let's go ahead and draw some lines. This would go from here to the negative input of the op-amp. We're going to go from here and cross over without touching the other wire right there. Okay, we're going to create a forward wire where we will sample our V out from. Let's go ahead and do this and put this one from here to here, and then go from there to here, and then, oops, should have been like that, and go to this resistor. Let's go, well, let's put a capacitor here and a capacitor in parallel, capacitor in series here. That is pretty much the construction of the Wien Bridge as far as we're concerned. Let's put this one here. Let's go ahead and pick up some capacitors. So we're going to go ahead and pick up cap. Okay, I need a vertical one here. That will work. Let me just stay as far away as possible from the other one, so I can actually put some values right here. And then Control R to flip it around. We're going to put it right here. Okay, that looks good. Let's continue with wires, and then we'll put our reference wires. And then after that, we set up the simulator and see what kind of results we're going to get. Let me just go around all the way across here. There you go. And let me just go from here like this, continue with the circuit. Let's go over here. And let's go to the positive feedback right here. Voila. Let's see if we have the circuit. Perfect. Yep, that looks good. So now we need to finish up the references right here and right here. So let me just go ahead and put some references, which will be our grounds. I need one right here, and I need another one right about here. Let's get some wires. It's a bit tedious, but once you get it, and you have yourself a nice little circuit. This is way faster than doing it in the lab, by the way. So, but nothing beats the experience of doing a hands-on in the lab, okay? So as I said before, this one will be my my feedback resistor for the inverting input. And this one I intended to do 30K here. Just 30K will be just fine there. And this one I intended to be 10K. So 30 over 10 is 3. Okay. And for these, now I've calculated this already ahead of time. If I pick a capacitor of 0.01 microfarad, then the resistor I'm going to need is 1.5 kilo ohm. So 0.01 microfarads for the capacitor. We're going to do the same thing here for this one. This would be also, again, 0.01 microfarads. Okay. That forces these to R values, which should be the same, okay, to be 1.5 kilo ohm. Now, if you do want to experiment, you could start tweaking this R and this R to make them different, to make them higher together or lower, and see what your sustained signal looks like. Okay. Right now, my intent is to get it to work. So, and it's very, very sensitive in terms of getting this to work. Okay. You're off by a little bit, and it will not work. I've experienced that before. in the real circuit when you build it in the lab, and or here. In the lab, it's even harder. Okay, so once we have this, now we need to set up the simulator. So that means we're going to tell it over how many seconds are we sampling this for. So for this, I'm just going to go ahead and draft what we call a SPICE directive, right? So we've done this before on transistor circuits for the DC analysis and the AC analysis. And this one here will be the transient analysis, so dot tran, okay? And then specify the amount of time. So 0. maybe 0.01. Let's see what happens, okay? I might have to go to 0.01. We'll see. We can play with that. And there you have it. So the trans is right there, okay? This is ready to run. What I like to do sometimes is put a label right here where I would want this one to be, let's say, V out, because you're measuring V out versus ground, right? So we're going to be anything you measure. So I'm going to put my probe here. Whatever voltage I get from here is always vis-a-vis ground, either here, here, or here. So these three prongs here are all connected to the same, to the battery where the two batteries connect, the minus and the plus connect together, okay? All right, so now we're ready to run this. So let's go ahead and run it. And you can see here we get this graph here. And what I'm going to do now is move over here and put my probe right there. And sure enough, here you go. So notice it's a little flat at the beginning. And then boom, it starts oscillating from there and it's sustained. Okay. So now these values here will play a huge role on how this will work. So let's go ahead and modify that for a second, just for giggles, to see what happens if you go by 1/2, right? So I'm just going to go over here and put 15 and see what happens. Of course, I got to turn off or close this and run it again. Put this over here. We get to see some weird results here. Well, actually, it worked. Let me just make it a little bigger right there. And the idea is we want to get this as much of a sine wave as possible. The reason it's getting flat here is because we're hitting saturation. Remember, you have plus 9 volt for VCC, minus 9 volt for VEE. We're getting really close to that. The op-amp will saturate, the output will saturate, will not give you any higher than that. So we're clipping in here. So we would like the signal to be a little lower maybe, so we don't clip as much.